Okay, so we're going to look now at solving fractions by eliminating the denominator, okay, eliminating the fraction element. And there's a simple enough method we're going to use for this, and really all that we're doing here is actually just kind of reordering the steps that we followed in the previous method. So what we're going to start with is still find that common denominator for all of the fractions, and we're going to look at the entire question, all of the fractions in the question, and we're going to find what that common denominator could be. We are then going to multiply every term in the question, in the equation, by that common denominator. What we're hoping to do here is by choosing a number that is a common multiple, we are sure that every denominator in the question will divide into that number. Okay, if I have, like we have here, two denominators, 5 and 2, the lowest common multiple, the lowest common denominator I could pick would be 10, and I'm confident, obviously, that then 5 divides into 10 and 2 divides into 10. And what this does then is it just removes the fractions from the get-go and leaves us with a standard enough equation that we should be able to solve based on our kind of knowledge of algebra from Algebra 1. So let's apply that here. First step still is to find the common denominator. In this case, for 5 and 2, the common denominator would be 10. What we're then going to do is we're going to be multiplying both or all of the expressions in this question by 10. Okay, so plus, sorry, it doesn't like me changing colors clearly. Doesn't like it. Let me see, I might try and cheat it a bit here. Okay, perfect. Right. There's a tiny little bit of explanation to go here. Okay, there is a tiny bit of explanation that we need to do here. So I'm multiplying each expression by 10. That's my lowest common denominator. What we think about in these situations is we're focused on this expression, the 2x minus 1. Okay, and what you need to do is you need to kind of describe what's happening to that expression here. Okay, if I'm multiplying by 10, another way that I would write that would be 10 on the top. Okay, it would go on the top. So that would be an alternative way for me to write what I have written here above it. Okay. What that, I suppose, helps us to see is that this 2x minus 1 expression is going to be multiplied by 10, but also divided by 5. So our goal here nearly is to streamline that, is to reduce this down. So the way that we're going to do that is start with my 10 and divide the 5 in there. Okay, divide the 5 into the 10. Okay, obviously we know that that's just going to leave me with a remainder of 2. And the 2 will be on the top of the fraction because I suppose it's left over from the 10. So I'm left with 2 times 2x minus 1. Okay, so I've divided the denominator, the 5, into the 10, which leaves me with 2. Let's have a look at that again with the second fraction here. So it's 10 times x plus 7 all over 2. We're going to divide the 2 into the 10, which leaves me with a remainder of 5. So that leaves me with 5 here. So 5 times x plus 7. On the right hand side, the 6 was just multiplied by 10. That's just 60. Now we're at a point where we can multiply out our brackets here. And we should recognize from the previous video that this is actually just the identical equation. We've essentially just arrived at the equation earlier than we did in the previous video. So this idea that multiplying the entire equation is going to allow me to eliminate those fractions. I'm taking an expression like the 2x minus 1 there that is divided by 5. I am multiplying it by 10, which has the overall effect of multiplying it by 2 because the 5 divides into the 10. Similarly on the second one, it's divided by 2, but it's multiplied by 10, so the 10 divided by 2 gives me 5, so now it's just multiplied by 5. This can be a simpler method or a more kind of streamlined method, if you like, and it probably is the preferred method solely for equations. The only reason this is possible is that for an equation I am able to multiply across, if you like. I'm able to multiply the entire expression by that common denominator. So let's just pick one or two of these to do as examples here of this method. So I have a few different ones I would like to look at. Let's start with one that's a little more straightforward. Let's start with this 2016 one here. Actually, sorry, that's the same denominators. Let's pick denominators that are different at least. Let's try this one. Okay, so x minus 1 over 3 minus 5x plus 2 over 4 is equal to 1. First step, as always, find my lowest common denominator. Here, that's going to be 12. My next step now is going to be multiply each of the fractions by that denominator. Okay, 5x plus 2, 1, making sure we multiply the other side as well. Because remember, if we don't keep it balanced, then we've changed one side but haven't changed the other. The equation is no longer the same. My next step is to divide the denominator into that 12 and see what I'm left with. Here it's 4. On the next one, it's going to be 3. And on the last one, it's the full 12. Multiplying some more of this out, 4x minus 4 minus 15x minus 6 equals 12. Let's reduce this down. Minus 11x minus 10 equals 12. Minus 11x equals 22. So x equals, by dividing by minus 11, x equals minus 2, or negative 2 there. So hopefully we're getting a sense of the idea there. So we multiply by that common denominator, then we take the denominator on the fraction, the 3, and divide it into the 12. We take the 4, divide it into the 12. See what we're left with. Here we're left with 4, or with 3, excuse me. First one was 4. Okay, so let's look at one that is maybe a tiny bit more complicated as well. Let's look at this one here. Okay, a good example for us because it brings in a few different elements. So, and this is a Leaving Cert ordinary level question. So looking at the fractions, we now have 3 fractions. Okay, if we were following the simplifying method, I would nearly say we could bring all the fractions to one side, or we could maybe just simplify the left-hand side. We are going to follow this other method instead though. So the first thing to do would be to look for the lowest common denominator. We're going to go with the entire fraction. So we're going to look at the 2, the 3, and the 4. We want to pick the lowest common multiple for all of those, which is actually going to be 12. Okay, they all divide into 12. So my first step, I suppose, is going to be multiplying each of those fractions by 12. 9x minus 6 over 2 is equal to 12 times 3x minus 14 over 3 plus 12 times 9x over 4. So let's put all of this together now. So we're following our new method that we have. We're multiplying it by 12, but the first one here has a divide by 2 as well. So let's see what that leaves us with. That leaves me with 6. Okay, and you may get fluent enough at this that you even leave out the first line and you're able to just go to the second line. Grant, absolutely fine. Let's look at the next one. I'm dividing the 3 into the 12, which leaves me with 4. The last one, I'm dividing the 4 into the 12, which leaves me with 3. Now I'm left with a single equation on one line that I should be able to solve fairly fluently here. So let's put it all together. 54x minus 36 equals 12x minus, let me see, 14 by 4 is 56 plus 27x. Okay, solving an equation as normal, we maybe want to move everything to the one side, kind of arrange it in that way. Remember what I was talking about earlier, talking about inverse operations. What we're really doing here is you're subtracting x's from this side, doing the same to the other side. Okay, able to put them up in that way. Minus 12x, or we just think about it as moving them over. Same thing with the numbers, minus 56x, and adding 36 to the other side. Okay, kind of combining them in that way. Let's see what this leaves you with. 54 minus 12 minus 27 gives you 15. So 15x is equal to, let me see, minus 20. I'm going to divide both sides by 15 to get x on its own. So x is minus 20 over 15, which does reduce down. Okay, thinking about how it reduces down, we're basically dividing both of the fractions by 5 to get 4 over 3, or negative 4 over 3. Okay, so a big element really with our fractions here is going to be obviously common denominators. It's going to be that ability to divide the denominator into any number that might be multiplying it, and also that ability to even just divide the denominator into terms that are above on the fraction. Okay, and even simplifying fractions like the one we had there at the bottom, kind of having that understanding of why that is happening or why it works here. So two different methods. This is probably maybe the preferred method for solving the equations, but the other method works equally as well.